number video emphasises the importance of arithmetic and includes a recap of why we need symbols, that is numbers, to represent quantities and why our number system is based on 10. The basic operations of addition and subtraction are also covered.
What was the very first kind of math that was developed by the human race? That would undoubtedly be arithmetic. Shortly after humans were able to count, we needed symbols to represent those counting numbers, as well as methods to manipulate those numbers in ways that represent real-life concepts. Once civilizations formed and we began to trade goods with one another, we needed to be able to keep track of inventory, price items appropriately, and so forth. How many apples are in the basket? How many do you want, and how many are now left? Being that we like to count on our fingers, and we have 10 of them, many counting systems were based on a system of 10. Getting back to the apples, the basic operations we will learn first are addition and subtraction. Addition is the most basic arithmetic operation, and it represents the combination of two numbers to become a single number, or a sum. If you get 2 apples from one vendor and then 3 from another, how many apples did you get? Of course, we can easily count the resulting pile and see that there are 5. But how do we represent this mathematically? Using the symbols that are common of today, we would put the number 2, then the addition or plus symbol, and then the number 3, followed by an equals sign, and then the number 5. This is an equation, which is a statement of equality. The expression on the left is numerically equivalent with the expression on the right. This particular equation reads 2 plus 3 equals 5, with the word plus essentially meaning and the equals sign meaning is. 2 and 3 is 5, so 5 is the sum of this additive operation. The next operation that became necessary was subtraction, which is the inverse or opposite of addition, in that it doesn't find the sum of two numbers, it finds their difference. You bring all 5 of your apples home and you eat one of them. If one apple has been subtracted, how many are left? Again, it is easy to count and see that there are 4 left, but this result can also be calculated, which is much different from counting. We can write another equation with a 5, then the minus symbol, followed by a 1, then the equals sign, and the number 4. This reads 5 minus 1 equals 4, which essentially means 5 less 1 is 4. So 4 is the difference between 1 and 5. On a number line, this is the distance between the two numbers, and this is an excellent way to visualize subtraction. 14 minus 11 is 3, because 3 is the difference between the two numbers. It takes 3 to get from 11 to 14. Now that we have become familiar with the symbolic representation of these simple operations, we should discuss some applicable properties of numbers. Addition is commutative, in that the order in which numbers are added does not matter. 2 plus 3 equals 5, and 3 plus 2 also equals 5. Subtraction is not commutative. It does indeed matter which number is being subtracted from the other. 3 minus 2 is not the same as 2 minus 3. Addition is also associative. This means that if performing 2 successive additions, the order in which they are performed does not matter. 2 plus 3 plus 4 will be 9, no matter which numbers we add first. We can add the first 2 to get 5, and then add that to 4, or we can add the latter 2 to get 7, and then add that to 2. The result is the same. Subtraction is not associative. If we write down 5 minus 3 minus 2, we could do 5 minus 3 first. That gives us 2. And subtracting the other 2, we get 0. If instead we do the 3 minus 2 first, we get 1, and 5 minus 1 is 4. So we can see that subtraction is not associative. We will learn all about the order of operations later, as well as other ways in which these kinds of properties become less obvious, yet very important.
Now log into your Socrative student account and have a go at the addition and subtraction quizzes.